So for a reference, I originally did a raw PA file, did the par command to look at it before the workload was starting. So I'm going to start off with that one. Par, 3 big S's, read into it raw PA file, put it into a report. So it's converting that ASCII par or binary par file into an ASCII report. Now, if I don't have high system time, I don't care about this. And right now, 2-3% system time isn't very important to me. But if I were 60, 70, 80% system time, then it would be important to me. So now I VI that report. It's kind of where we are in the workbook, this par command. We're going to come back to it this afternoon a couple of times, but there are 3 basic par options: par-s, par-r, and par-k. Par-s tracks my system calls. Since I had high system time, that's why I'm interested in the par-k. I'm sorry, par-s. So looking at this trace, this is a par-s trace showing me the time since I started par, the CPU number that I'm on, and then the program name and PID, and then lastly what the system call is. So in a multi-threading situation, block proc and proc CTL, PR is block. It's what the parent is doing to talk to the children to say, are you sitting there locked waiting for barrier synchronization? So each of these I see the start of the system call, and then I also see the end of a system call. And then for any of these system calls, you do a man, like do a man on PRCTL or do a man on unblock proc. So we get the time since par started, the CPU number, the program name, the PID, and then what the system call was. By the way, some of the system calls will have an equal sign after it. The stuff after the equal sign is the return status from the system call. So in this case, I had a PRCTL that returned a 1. And I have to go to that man page and say, well, what does a 1 mean? For example, with I/O, when I do read and writes, the return status is the number of bytes transferred. Now I'm going to go to the end of this trace, because at the end of the trace is my most important report. So at the end of the trace, it's giving me my system call summary. So I get the name of the system call, then I get the number of times that call was made, then I get the average time per call, and lastly the total time during the interval on the call. So this particular sample, select SGI-NAT, block proc, and read, and a little bit of sys-SGI. Those are my top 5 system calls. But again, I was only 3 to 7% system time versus 70 or 80% system time. Okay. So this tells me what the top calls are. If I have high system time, these are the ones that I want to find out, and then I have to go back in to find out who is making that call. So since select is the top of the list, let's grep for select. And I see gross view is probably the main thing that's causing that. I also see MMSD, which is the LCD display. SMTD, but most of it looks like gross view. So most of that, and telnet is in there. PTC and a few other things, PMake and stuff like that. So this then is listing all the processes that are making that system call. And most of them appear to be gross view.
Which would be right, because it does make quite a few calls to get its information.
And that's an example where the profiling tools are showing up in the report. So I can VI RPT and then look for gross view and then see all the different types of system calls that it's making. So there was a read. Here's a read that's done, and then we do a write. And with reads and writes, by the way, the first field is the file descriptor. 0, 1, and 2 being standard in, standard out, standard error. Then we've either got a pointer to the data or sometimes the data itself. And lastly, the number of bytes. So here gross view is reading 4 bytes. And again, it's a 64K byte buffer that everything's going through, and we're wasting 64K of it. And to the right of the equal sign then is the return status, which was the number of bytes actually transferred by gross view.
What's the first one again?
That's what's called the file descriptor. The file descriptor is every time I open up a file within the process, I create an open file table entry. The file descriptor is basically the position into that table that my file is. So it's the order that I open them. So I could have a file descriptor 5, close that file down, open up a new file, and it would have the same file descriptor.
You find all the opens to find out what the name is.
For the Unix person, we're used to redirecting 1 and 2 in the Bourne shell, that sort of thing. 1 being standard out, 2 being standard error. So with Bourne, you can redirect those 2 file descriptors to a particular file rather than having them come to your terminal. Now the other trace that I had was raw 1 file. I'm going to put it into rpt.1. I'm going to edit rpt.1. Now the 3 S's gave me the most verbose report. I could have done a single S and got just the summary. So now I'm going to go to the end of that report again, and this time select is still up there, SGI-NAP is second, read is third, and block proc is fourth. And after that they drop off enough to where I don't care. So there wasn't a whole lot of difference between the 2 intervals. The workload hadn't changed that much yet. By the way, up here in the window, I can see where code 2MP is making the SGI-NAP calls and what the actual value is that it's napping on. Nothing's running right now. Okay. So let's see if this is going to work. Remember what load problem I had yesterday? I brought the load level up to about 70, right here, up to about 70. I'm going to do it again now.
Can you repeat what the SGI-NAP do again?
The SGI-NAP is a system call to give up my CPU.
Okay.
It's simply a way of saying, here kernel, give the CPU to somebody that can use it. And the multi-threading libraries are the key thing that uses it, but we also saw a couple other commands that it's like a sleep.
Okay.
Except sleeps have a time to it, whereas an SGI-NAP says, wake me up when you're ready. Whereas a sleep says, wake me up when my alarm goes off.
Okay.
Now what I was going to try to do was 45 processes. And I threaded it. Okay, so I just fired off that same script we had yesterday. Look at my load levels now. I've got 163 threads or processes that are running or ready to run. See what my load level's like. Oops. There we go. A little bit of pause there. Let's see what we got. So I'm doing a 1 to space 15. So I've got very high user time, very little bit high system time, but no I/O wait time associated with this. So I've not oversubscribed memory. The performance event that I just had a few seconds ago, I can't tell what was happening at that time. But based upon this assumption, it looks like that was mostly CPU wait. Let's see what W is looking like. So my load average is at 39. SAR-Q, and it is, I'm feeling it slow down and stuff. So my run queue size is on the order of 20 to 30, 15, 20, 30. I do have some stuff on the I/O queue as well. But still very, very little wait I/O time occurring. So I am getting a little bit of response issues here. Let's see, waiting there. IRIX. That's not too bad. I'm not doing any CPU work with VI compared to what Code 2 is doing. See if I got anything else going on. PS-EL, prep for Code 2, MP. Hasn't caught up yet. Perfect page. So, looking at all these Code 2 MPs, I can now see what flag they're waiting on, and gang SV appears to be the flag that these things are all waiting on. They're all in a wait state. So this almost looks like gang scheduling. I'm not sure why that lock is marked that way. Let's check something here. I do have a G in front of them, so they're all sitting there waiting on the gang scheduling. I said that that was going to be bad. For some reason, the gang scheduling is on by default. It wasn't that way before. Waiting. So the events that we are experiencing now are due to CPU wait time. Yesterday, the response was pretty good. Now we're much worse. W still shows a load level of 23. If I bring up top, so I've got 723 processes that are sleeping, or 6 right now that are ready, and 15, 16 that are running. Okay. But the rest of these that are sleeping are waiting on that gang save metric.
What are the 5 that are stopped? Where did those guys come from?
I'm not sure. I don't know which ones they are right now either. I'm still looking at all these other Code 2 MPs, and a bunch of them are still sitting there on that gang save lock. So my load level isn't as high as it was yesterday, yet I've got a little bit more severe response time because I've got more processes in there, but they're all sleeping doing this gang save type of call. Exit out, go back in. I turned gang scheduling off this time, so let's see what happens. There we are. Now this time, it looks like I still had a couple of gang threads that were cleaning up from before, but this time there's no G in front of the priority, and everything is running as non-gang. But I still have a whole bunch that are sleeping. Let's see what locks they're sleeping on this time. Now we're having a PS command take a little while here. Probably don't have JA turned on either.
Why is it taking forever?
Because the process table is busy, as PS is trying to go into the process table. So I'm able to log in interactively right now.
I did an LS and I can't get anything back yet.
The LS is taking a while too. Got a hunt system again. Let's see. I usually, when I'm like this, I like to do a date command twice. That basically writes a record into my accounting data, so I know what data to go back to. So October 18th at 14:29, I'm starting to experience some events. There, my PS finally came back. And everything is sitting on this lock. And that lock is my swap lock, I'll bet. 14B0F28. In earlier releases, it actually had a name, and then somewhere around 656 they changed it and never put a lock name on it. SAR 1/15. So some of my slowdowns right now do appear to be memory related and swapping related. No, I don't see it there. Nothing going on there.
You're not doing physical swap, right?
What's that?
It's not doing physical swap.
Oh. So all these events are due to the CPU scheduler. See if I got any swap going on. There is swap going on. Again, it varies from release to release, so for some reason that swap metric is not showing.
See a fairly high amount of interrupts showing up.
That'd be for all the IO duns. Oh,
How
so
many copies of that process you run?
Yes.
how many did I run?
Yeah.
1,000?
About that. Let's see, PS, EF,
Oh, okay.
grep, code 2MP, WC-L. I ran 64 with like 8 threads wide. I forget what my thread width was. So this bothers me. This is a 6-5-10 difference, but normally when I start seeing block activity, I've got swaps going on here, block swapping in. That should normally make the weight swap show up. And remember what I said where the locks bothered me before? These are the same locks. This is the buff lock, and this was supposed to be the BIO lock. So for some reason, I'm not seeing that show up, even though I do have physical swapping going on. So I had 1,310 code 2MPs on the system right now.
Oh, okay.
And then, again, that's multiple threads per process. But my load level is still low because everything's sitting there waiting. Let's see what the load level looks like now. Oh, there we go. So before, when I had gang scheduling on, everything was sitting there sleeping on the gang lock. Now that I got rid of that gang lock, everything is sitting there trying to run. The load average is now 500. Yesterday we were in the 70s.
Oh.
Okay.
So that's 523 processes that are not running on the system.
Some of them are, some of them aren't.
Okay.
There's 16 CPUs, so only 16 of them can be actively running. The rest of them are waiting to run. They're on the run queue, ready to run. If a CPU were available, then they get scheduled to them. Swap-LN, I just want to check here. Since we do have swapping going on, some of my performance events are due to the swapping. Those stalls that I was bothered by, that wasn't the thread width, but I kept getting fooled because when I look at this wait swap, it wasn't showing anything. But then when I went to SAR-W, I did see the swapping going on, with a lot of swap outs. 11,000 blocks per second being swapped out.
Well, that means then the gross view is broke also.
Whatever the kernel, yes.
All they changed broke a bunch of stuff.
Yeah, all the tools, the kernel's giving a number that's different than before. And it goes back to what I was saying before, the buff and the BIO locks seem to have changed the way they're being used in the kernel. And again, nobody really tests for these kinds of behaviors when they release the OS. So I do still have free memory, I do have free swap, but if I look at it historically, still 1 in the morning. I'm expecting these applications now to fail pretty badly. We've oversubscribed the system. We're going to have a lot of CPU wait time. We're going to have a lot of barrier synchronization problems. So here we can see, what was that, about 10 minutes ago, when my memory shortage problem started to occur. And I'll check to see when I actually ran the script here. Was it, no, wrong directory. So note, if I just hit carriage return, I still have a fair response. By the way, let me do an XACTL session info and see what I see there. So the biggest lock that I'm still seeing interactively is this blocked IO wait time. Since I've logged in, the biggest one though is my run queue wait time, right there. So most of the delays that I've been experiencing have been dominated by the run queue wait. It's almost 10 times more than the block IO wait, 100 times more than the system time. So most of my events are stalling on that. If I do a JA, I can start Java counting. Need to set an environment variable. Permission denied.
D-U?
Let me do a dash T. Maybe before I do that, dash C. See, it was already on, so when I tried to turn it on, it rejected it as permission denied. But again, this JA is not giving me the right data. Because I'm seeing code 4 in here, and I didn't run code 4 interactively. So I'll have to watch for that. So how are we doing? SAR-W, 1/15. So we do still have some swapping going in. The swap outs are done. Remember, some of that stall out could be just creating the pages for all these processes. I fired off, what do we have, 600 of them or something like that? So my load level. My load level is still in the 500 range, and SAR-Q will also be in the 500 range. Okay, 511, 504. That's the number of processes that are on the system running or trying to run. Also do have some wait IO events going on here. Let's see if I can catch those. ES-EEL, direct for buff. Let's see if that one works. I have 1 to 6 processes waiting on IO. There were none that showed up with the buff lock, though I would have expected it. And none showed up with the BIO lock either. If I can catch anything else. Of course, the event may be done and my IO has finished as well. KTWA.
Still games, this one.
There's one of them that's still in gang mode. That is one that I ran. In fact, here's the rest of it. This, by the way, is page table creation. So when code 2 is starting, that's the page table lock. But I'm not seeing any IO lock except 14B. No. By the way, if it has just a number next to it, that's an indication of a terminal driver. So if it looks like that, PTS/6 says that that's a terminal driver. You look over on the left, it's the shell. So if it does have an address like that, that's just the address of the terminal driver, the interrupt handler for that particular terminal.
What did W000 mean at the front?
The field is a null zero termination. So they didn't bother printing those as spaces.
Oh, okay.
So they're stuffing the field that had all zeros in it with the character string, and then the rest of the field is just showing up as zeros instead of null or space. So you ignore the zeros at the end, that's correct. I was kind of looking for swapping processes, and I was looking for, I still have a lot of that gang stuff going on. I'm just wondering if that's from my prior run. Bring up top again. Also, let's see, SAR-B. So top is not showing the gang save and the ones that are actively running, but I can't see everything. But here my process table went from 93 to up to 1400 now. 500 of them were the ones that were running and ready to run, like these. And then the other ones were not ready. Those are the ones that were on the gang save. What I suspect happened was I was in the C shell, and when I logged out, it was an implied no-hop. So I logged out to get rid of it, but I suspect that the script that I left is still running. That there is the other go.bottle that's now a no-hop type of process. So I've got that go.bottle experiment running twice now, one with gang on and one with gang off. And note my number of processes sleeping now is in the order of 900. 495 of them are ready, the rest of them are waiting on that gang lock. Here we had 18 running, 16 CPU system, but that would be a rounding problem. Again, my user, my waits, S-breaks, interrupt handlers are all tolerable. And it is a groggy system, but it's certainly not 20 minutes on a man page. If I do an LS, we were seeing a few more severe events a few minutes ago, which was due to the swapping. Now, man has to get buffer cache, and that's probably what's taking this a long time. Let's see what we got here.
I tried to do a bar, but I couldn't.
You have to be root.
I'm rude now.
Okay. And do a par-s, big O, name of the file. That was kind of a slow LS, as well as quitting out of LS, out of man.
It's funny. You want me to kill off your process that
It'll
has the
stay there
files?
forever, you know.
Found the head.
Gang? Yeah, because the parent's one.
Yeah.
You want me to kill it?
Yeah, you can.
I can't. I'd have to be rude.
Okay, so it's collecting it, and then you can get a carriage return or Control C to break it out.
Kill 9531.
requires me to get out of math too. Well, look at, I got 400 buffers, 325 of them are inodes. I've got 71 buffers left for data, 4 are empty. But the big thing is, note this display has things shifting in it up and down. It's not doing it too bad right now. But what was that?
9531.
So over here, I'm able to see it's changing every now and then, and things are changing position in that particular secondary cache. I'm sorry, file system buffer cache. I'm also going to try looking at busy flags, see if I can catch that. So there is some contention going on. In fact, right now I can see that it's inodes and stuff like that in the do_ptemp file system. And these are the ones that are busy at this particular time. Not too bad, only 3 buffers that are busy out of the 400 buffers. There's a compiler coming in, there's a C library. Question marks, by the way, indicate that it's a long name, and we didn't want to do a long name lookup. Like those.
Now that's BuffView.
That was BuffView. So I'm just kind of poking around with the system. Since man was taking a while, that's why I was interested in BuffView. And it's still pure CPU bound, no I/O problems. Let's see about memory. So we do still have swapping going on, and that wait swap flag is funny. Now these effects I'm talking about that I've been seeing, they seem to have changed in 659. Because I saw some of them in my last class a couple of weeks ago.
You're not going to believe this.
Go ahead.
Killing that off did not kill off those gang processes.
What was the process then?
9531
Was that bottle?
That was bottle, yeah. Let me find 531 was a bin sh go bottle 64.
Yeah.
Got rid of it, and then everybody that was under it now owns his own one.
Right. And they have to finish their service time or terminate. I killed the parent, but that did not imply killing the children.
So they gotta wait for them all to time out first.
Right. I could do a kill all, but then I'd end up killing the ones that are actively running versus the ones that were the gang ones that I wanted to get rid of.
Now get rid of half your processes. Once those die off, they'll free up half of them.
Right. Were you going to change tapes or
No.
just take a break? Now, why don't we take a 10-minute break? And at this point, what do we want to do? We want to go on to file systems. We want to come back to par-s. So I was looking a little bit at par-s, and there was something I want to look at, but let's take a look at that when we come back from lunch. Or I mean, from break. Okay? Yeah. But the swapping is real low now.
Now, which one are you calling the BS?
Blocks swapped.
The BS win? That one right there?
That's the number of blocks swapped. So I'm just trying to watch this. Blocks of swapping is occurring, but my percent swap is still staying 0. That was not like that in 658. Started noticing it 2 weeks ago in 659. I'm going to have to talk to somebody called Mark Courtney and see if he's seen this.
Oh yeah, that's 984.
Anger, info.engr. So in info.engr you can find the product pages. So here's 6510. And it's supposed to release to manufacturing October 18th. That's why I grabbed it this week. And then field coverage, November 8th.
For FCM, first customer ship.
Right. And then if I pick 6511, that's what we're seeing now. Development ends November 29th. So I should complain to them about the things I'm seeing in 6510 and see if it's a valid complaint.
Is that all the stuff they're doing, RAS, what? Reliability.
Enhancements to reliability.
RAS. I don't know what RAS, what they're referring to as RAS.
Yeah.
Does some CXFS fail-safe.
Being able to coexist. And yeah, here's the release to January 17th. And if I actually want to install it, right down here, we got release schedules, stuff like that, bugs, testing, how to build it, where the source is. And the one I'm looking for is the actual installation.
Beacon, this one.
Now that's where the images, if I wanted to load them, this is basically where I went for what we're running now, except it was a 6510 path. What I'm looking for is the installation instruction. So right here would be my installation guide. You click on that, and then it goes through the whole process, as well as warnings and stuff like that. So being able to open up the distribution, and do the keep star, install standard, all those comments are there. But anyways, info.ingr is where I go for that sort of information.
Again.
Now, we're going to talk a little bit more about PAR and system time, and then we're going to go on to file systems. So we are rolling now? So I got a case study from a site. I'm going to see what I get out of it here. Not too good.
I said they got all CPU3.
What this means is the workload's so busy, the real-time monitor daemon can't track all the events. What the PAR is doing is it's talking to the real-time monitor daemon, which is then looking at the kernel. And there's actually a real-time monitor daemon for every process on the system. If my CPUs are busy, the kernel has an event number for everything that's in the traces that RTMonD is looking at. So in this case, CPU3 might have had something busy on it, like Oracle. And every time I went and grabbed data about what CPU3 was doing, the event number had slipped. So it's telling me that I lost a whole bunch of events in here. In other words, PAR could not keep up because everything was so busy. But I did still get data, and this was that real site that I was trying to show you. I got this a week ago. And undo is just called new site, or site_new. So in there I've grabbed the PAR data that they gave me from the site. Again, I'm going to do an X graph on system time.
There is, you know, all the calls that the system does. If you do a man in a system call, you would know what it is. Because
Yeah.
sometimes, I look at part traces and I don't know what
The only warning is that you need the 2 in parens after it. So for example, I did a read. One is the shell read, and then one is the actual, there's a Fortran read and a C read. The one you want has the 2 in parens.
Okay.
And we'll try that. But not exactly every system call has a man page for
Oh,
it.
really?
There are some system calls that are unique just to the operating system, and they didn't document them. They document all the ones that users and programmers use, but there are a couple of system calls that are unique to the OS that users should not be using. So those might not be showing.
There is no any documentation about those.
No, generally not. But that's only 3 or 4 of them.
Oh, okay.
That's not that many. Now what I was going to do here was look at my system time. So this is the data that they gave me. Customer called in and said my system time is high. And we looked at the data a little bit earlier today, or earlier this week. And when they grabbed it, it was October 4th last week when I got the data. Oops, I spelled something wrong here. So here's what my system time was like October 1st, 2nd, 3rd, and then on the 4th, it went up to 50-some%. So this was the beginning of the month. We looked at the data briefly yesterday. So we're running long. I would not be interested in a par trace on the 1st. Noon on the 1st, I had no system time. However, about 1 o'clock, 2 o'clock in the afternoon on October 2nd, my system time went from about 1.5–2% up to 50% system time. So if I'm going to use par, I better look at the right time. And that's where I need that reference, that baseline again. Question?
Well, what, 2:35? What, time-wise, about 2:30?
These are in fractions of a day.
Oh, day.
I do have the ability with the tool to put them into hours too, but these are designed by default to be days. So here's October 1st. It starts on the 1st. The 0 day doesn't exist. There's no data there.
Okay, so 2.50 would be noontime.
Noontime, that's
Okay.
noon. That black gray line there is noon. But there is under the legend the ability to drop it into hours instead of days, and fractions of hours. That's the one disadvantage of this tool. Xgraph doesn't know how to handle time. It's base 10. It doesn't know what to do between 60 and 0. Okay? Or when I wrap from the end of the month on the 31st back to the 1st. But it's still a good enough tool to extract data and visualize it. You just got to be aware of those limitations. So I then had them, and again at the end of the last month they were also very high, and then it dropped down again. So I want to make sure that when they're looking at this par information that they're at least about 15–20% system time. Because most of the time it's between 45 and 55% system time. So they did happen to run a par trace during that interval. And where did I put that? And that was what I got here. So again, at the top of the list, I've got select, semaphore operations, LSEQ, reads, and writes. SGI NAPS, PRCTL. So again, I can do a man on most of these. We'll try a couple of them. Let's try a receive from or something like that. But this is the number of calls, average time per call, and then the total amount of time during that interval. So if I did a 10-minute or a 10-second sample and had 100 CPUs, that'd be in parallel with all those CPUs. So that high system time then would show up. Select was one of them. Then SEMOP was half of it. So if I do a man on select, it's basically a network synchronous I/O multiplexing across the network interface. The other one I had was a man on SEM-op, and that was my semaphore operations. Okay. Now the select is I/O, and that might be bread and butter for a database engine. Everything I pump into the database engine is coming from select. So there are going to be good system calls and there are going to be bad system calls. Some systems, they don't want system time more than 5%. But if I go off onto a web server or an NFS server or something like that where its whole purpose in life is to do I/O, I'm going to expect to have system calls higher. Okay? So compute servers, they like system time as low as possible. So some of the good system calls for par, we'll come back to R and K later, tomorrow actually. So good or normal would be things like read, write, LSEQ, open. These are things that you have to do. LSEQ is where I do random I/O. I'm positioning myself into the file rather than sequentially striding. And we also just now saw select. A computer's no good without doing I/O. So these are what I would consider normal types of system calls. So there has to be something at the top of the list. Okay. So let's make them productive system calls. Now if I were on this compute server, 2 or 3% system time, all of it being reads or writes might not be bad. But if I go to an NFS server, I might have 40% system time and all of it being reads or writes. But again, that's the purpose of an NFS server. Bad system calls. First of all, S-break, which was my memory growth and shrinks, IRIX. Also something like SGI NAP. I was trying to drive the system time up more with SGI NAP, but in 6510 that seemed to be a lot better. In 657, 658, SGI NAPs would drive the system time up to 70-80% with the experiment that we just did. Now, that's my disadvantage with this class. Every time I teach it, it's a different OS, and the behaviors are not always predictable. And I'm seeing differences because I do this class every month with the same workload, but same hardware, same applications, but a different OS underneath, or different library compiler sets. Other bad system calls, if I think of any. One of my favorites was get time of day. Every time you make a system call, there's no guarantee you get your CPU back. You name. I found programs that have been doing these types of calls 100,000 times a second. Again, 20 years ago, that program, it was okay to do that. But nowadays, with super fast CPUs, I don't need that high intensity system call, and I can move them out of a loop and put them somewhere else. The semaphore operations that we just had, semops. And what's going on here now looks like it's thrashing. Now, I have not heard back from the site to see if they've resolved their problem and are correctly running. But looking at their trace now, going back to par-3 S's instead of 1 S's on that PA file that I've got, the RPT. So I'd gotten the summary report a few minutes ago. I used SAR to say I've got high system time, and then I used the summary report to say my top system calls were select, reads, and writes. Now I want to know who's making those operations. Semops was the other one that was bad there. So little s collected the data, and then the big S's give me verbose reports. 3 S's being the most verbose. Before I used just a single S, and that just gave me a summary. And it's still running. Let's just see something.
Weights on TS's? T-stamp? Timestamp? Wait.
That would be a timestamp probably. Let me filter just for par. Oh, it's back already. Done. I just missed it. So my report did come back now. So if I do a tail minus 150 on RPT, that's what we were just looking at. So there's my top system calls. Now I'd be interested in knowing, okay, who's doing select, who's doing semops, who's doing LSEEKs, and reads and writes I'm going to live with. The reads are rather high, but again, the select and the semops are 80% of what's going on here. Okay, so now that I've got that file, RPT, I can now look into it, and there we can see again the name of the process, the PID, and what the system call is. So here, now I can start to see what this machine is doing, and it's running Oracle. And here's Oracle doing its selects. So the select is how it's reading I/O in and out. Also see an LSEEK in here coming from a program called Fast A3. And then I wanted to look for semops. So here is Oracle doing a semop operation. So I'm going to now grep for semop on that report. I'm just going to put it into X. And now I'm looking at just the semaphore operations or just the selects. I'm narrowing down what I'm interested in. EG on X. And now I see that they're all Oracle, but notice some of these are coming back. Interrupted function call in semaphore with an error number 4. And then it gets really bad. Almost every semaphore operation is coming back with that particular message. Okay. So it looks to me on the system that Oracle is thrashing, trying to do the semaphore operation, and notice that this number is different, but the actual tag that it's working on is the same all through it. So let's do a man on semop again. And it is paren 2, so that's my system call page. And the first one is my semaphore ID. The second one is the pointer to my semaphore buffer. And the third one is the size of the semaphore. I'm sorry, the number of operations. What's it calling it here? Number of structures in the array. NSOPS is the number of structures in that array. Now what I'm trying to find is what a 4 means if it comes back with an error code of 4. What were we getting? Error number 4, interrupted function call.
Just talked about at the bottom, again, if it returns due to the receipt of a signal,
The value of -1 is returned to the calling process. Now we're getting a 4 instead of a -1.
it says other errors which occur on SIMOPS are EINTR. SIMOP was interrupted
Right.
with a signal, or by a signal.
Right. And by the way, we could be looking at signals on the system too, but I don't have that data. But that's still going to give me a -1. And error null then is set to EINTR, which is this one here. But I'm getting a 4 coming back. Okay, and with the P error command, that just prints it to interrupted function call.
Let's see what the 4 is in signal. 4 on signal is a,
Now that's not a signal, that's an error number. So I had to do a man on intro. This is the intro to the system call document. So all your ERNOs, ERRNO, are documented on the intro man page, but I need the to intro man page. Now, I could have gone to erno.h to look at this information as well. So I paged down through a couple of them, then I got 1M intro, then I got intro for 2, and that's where I start getting my description. So an error number 1 coming back says operation not permitted. We had a 4, and there's what we were getting. An asynchronous signal, such as an interrupt or a quit, which the user has elected to catch, occurred during the execution of an interruptible function. So we were in the middle of doing that semaphore operation when an interrupt occurred. If execution is reserved after processing the signal, it appears as if the interrupted system call returned this error condition. Okay. So looking at this system, that semaphore operation concept, I would expect on this machine for IPCS to show semaphores proper. So this was the tag for the operation, and then this was the array, and this was the number of arrays that we've got. But the tags are changing. 208, 12, 312, there's a 12 again, 205, 12. Let me grep on select. Select was top of the list. And they are all Oracle itself. KSD in there, but that was interrupted system call. Now when you have high system time, it all goes back to the application. So in this case, when I'm looking at the par trace, all my system time, I do see Software Manager in there, but almost all the selects are from Oracle itself. Okay. And I'm just going to break out of there. Here we've got, again, the exit state is coming back as a 0. So we could look at the select syntax to figure that one out. Let me just try another one. Man on TS stamp underscore mask, see if that's documented. So there's one that isn't documented. Man, xstat probably is not documented either. But if you do a man on stat, there's my two. Stat, LStat, and FStat. They're not showing xstat as one of them. Now, with SPV, it's probably a little bit early to show this. I do have the ability with SPV of plotting some of the things that come out of a PAR file. Note that I now have the PAR button turned on because it found a file. If I do a setup, there is a path here. My binary PAR file is user people DAW PA file. Okay, and this was not the one that we're looking at right now, so I'm going to go into the new one. Site underscore new slash, what did I call it? There was PA file there as well. So now down here it tells me that it got it from site underscore new PA file. So if I go to PAR now, I can pop up total pie chart, and instead of ASCII I see the same data that we just saw with that summary report with the big S option. And by the way, PAR can be very expensive on your system. If I have a 128 CPU system, I get one real-time monitor demon per CPU. And if I'm doing 200,000 calls per second, there's going to be a lot of data there.
Got it.
Okay. So in this example, this is what we saw before. So out of that total number of milliseconds, select was almost a half, semops was a third, lseek was a third, then read, and everything else was other. But in terms of number of calls, lseek was the most common one. But that would make sense in the database engine because we're constantly seeking. So seek and select are rather high. And again, this all goes back to understanding the application. I can't do anything as a system tuner here. It's going back to the application. We also had read and time. I can't tell, it looks like just times instead of time stamp or something like that. Now the next ones I have are to look at just the reads and writes that are going on the system. I'm not expecting to see a whole lot because Oracle in particular is doing direct or raw I/O, bypassing the file system. Now the reason that this is handy is because the next step for us is to profile the I/O of the application so that we can set buffer sizes. So here now I can start to see my read requests. And this brown one, I've got one application that's sitting there going as much as it looks like 128, 127 meg in size. No, I'm sorry, 127 kbytes in size. And most of the others are under 8 kbytes in size. So what I'm looking at is every read and write system call, and then I'm grabbing the number of bytes transferred. And I'm also sorting them by program name. If I zoom down in here, I see that most of the I/O that's going on in my system is there's 8 kbyte, there's 4 kbyte, there's 2 kbyte, there's 1 kbyte. Now these are what I'm asking for on a read. What is actually occurring by the data is this one. And now I'm much smaller. There was one I/O request in there at 64K it looks like. But the rest of them are down here. There's 16 kbyte, and it looks like we've got a bunch here that are at 10 kbyte. And then most of them here are under 5 kbyte. So I've got a lot of data going on here that's very, very small. 4 kbyte, 2 kbyte, and lots of stuff that's even under, 512 bytes in my request size. So this is telling me in this particular PAR trace that I'm reading lots of little things. Okay. Let me check writes. to wrap up system time here in a few minutes, and then we'll start talking about file system layout. So I'm profiling everything, and with par writes now, I see that the writes are even much smaller than the reads. The reads were bigger. My writes are typically very, very small. And again, I only have 30 seconds of data here. Milliseconds times 10 to the third, so there's 20 seconds. I've got 30 seconds of data here. Yet from SAR, I had this high system time for days. So I got to make sure that I'm looking at the right interval. But again, 2 kbyte and less. And if they were striping, that'd probably be bad on the system. And then again, most of the I/O that's being written on the system is 2 kbyte or smaller. So it looks like I'm doing lots of little I/Os rather than a few large I/Os, which would make sense for Oracle.
Most of our R-log-MD stuff.
Could be. I wasn't paying attention. The colors will wrap, and then you have to start tweaking things to filter it out. So with PAR, I'm able to actually say, give me just a particular PID. But as a system tuner, I'm trying to look at the whole spread of everything on the system, so I'm not blind. And then I know that I'm going to take a look more closely at Oracle or whatever it is, and then try to follow RNet, RLOGMD or whatever it was. The third one that I'm trying here are my SGI naps, and I've only got a few programs doing those, so they're not part of my system time, but I got Tail, FC Agent, PG Daemon, and PM Dump Text. Which is kind of interesting to see that. I don't usually see that on a system. Okay. Now, I'm not going to use that par trace for the next example because it's too big for me. The most expensive tool on IRIX that will impact your system the most is called IRIX View. If I can find it.